According to the National Electrical Code, NEC, a disconnect is required on both the line and load side of the transformer. On the line side disconnect, it must be rated for the full transformer primary current. It must be a fused or unfused disconnect as specified by NEC Article 450.4. If unfused, it must be in sight of the transformer. On the load side disconnect, it must be a fused disconnect. It must be rated for the full transformer secondary current. It must be readily accessible. The line side disconnect provides protection against accidental energization of the transformer while it is being worked on. The load side disconnect allows for safe isolation of the transformer from the load in case of a fault or maintenance. The panel with the main breaker on the load side of the transformer provides additional protection and isolation for the downstream loads. If the transformer is used for voltage conversion only, without any change in the number of phases, the line side and load side disconnects can be interconnected. It is recommended to follow the specific requirements and guidelines provided in NEC Article 450 for proper transformer installation and protection. When installing transformers, understanding the NEC requirements for disconnects on both the line and load sides is crucial for ensuring safety and code compliance. These disconnects serve distinct purposes in protecting personnel and equipment. Let's delve into the specifics. Focusing first on the line side disconnect, this disconnect is essential for isolating the transformer from the incoming power supply during maintenance or repair. Its primary functions are to prevent accidental energization of the transformer while work is being performed and to provide a means of de-energizing the transformer in the event of a fault on the primary side. The line side disconnect must be rated to handle the full primary current of the transformer. This rating ensures that the disconnect can safely interrupt the flow of current under normal operating conditions as well as during overloads or short circuits. NEC Article 450.4 dictates whether the line side disconnect should be fused or unfused. This decision depends on several factors, including the transformer size, voltage, and application. A fused disconnect incorporates fuses that provide overcurrent protection for the transformer and the upstream electrical system. An unfused disconnect, on the other hand, simply provides a means of disconnecting the transformer from the power source without overcurrent protection. If an unfused disconnect is used on the line side, it must be installed within sight of the transformer. This requirement ensures that anyone working on the transformer can visually verify that the disconnect is open and the transformer is de-energized. Now, examining the load side disconnect. This disconnect is located in the secondary side of the transformer and serves to isolate the transformer from the downstream load. Its main purpose is to allow for safe isolation of the transformer in case of a fault or during maintenance on the secondary side. Unlike the line side disconnect, the load side disconnect must always be a fused disconnect. This requirement provides overcurrent protection for the transformer, the secondary conductors, and the downstream loads. The load side disconnect must be rated to handle the full secondary current of the transformer. This rating ensures that the disconnect can safely interrupt the flow of current under normal operating conditions as well as during overloads or short circuits on the secondary side. In addition to being fused and properly rated, the load side disconnect must be readily accessible. This requirement ensures that authorized personnel can quickly and easily de-energize the transformer in the event of an emergency or for routine maintenance. The rationale behind these disconnect requirements stems from the need to protect both personnel and equipment from electrical hazards. The line side disconnect prevents accidental energization during work, while the load side disconnect allows for safe isolation during faults or maintenance. Together, these disconnects create a safe working environment and minimize the risk of electrical accidents. The panel with the main breaker on the load side of the transformer offers additional protection and isolation for the downstream loads. This main breaker acts as a secondary overcurrent protection device, providing an extra layer of safety for the electrical system. If the transformer is used solely for voltage conversion, without any change in the number of phases, the line side and load side disconnects can be interconnected. This interconnection simplifies the wiring and control of the transformer system. However, it is crucial to ensure that the interconnected disconnects are properly rated and coordinated to provide adequate protection. NEC Article 450 provides detailed requirements and guidelines for the installation and protection of transformers. It is essential to consult this article and adhere to its provisions to ensure that the transformer installation is safe, reliable, and code compliant. Here are some additional considerations for transformer disconnects. Firstly, the size of the conductors connecting the disconnects to the transformer and the electrical panels must be properly sized to handle the full current of the transformer. Consult NEC Table 310.15 to determine the appropriate conductor size based on the ampacity and insulation type of the conductors. Secondly, the overcurrent protection devices, such as fuses or circuit breakers, used in the disconnects must be carefully selected to protect the transformer and the electrical system from overloads and short circuits. The overcurrent protection devices should be sized according to the transformer's nameplate rating and the applicable NEC requirements. Thirdly, the disconnects must be properly labeled to clearly identify their function and the equipment they serve. This labeling helps to prevent confusion and ensures that personnel can quickly and easily locate the appropriate disconnect in an emergency. Fourthly, regular inspections and maintenance should be performed on the transformer disconnects to ensure that they are in good working condition. This maintenance includes checking for loose connections, damaged components, and proper operation of the disconnect mechanisms. Fifthly, it is important to consider the environmental conditions in which the transformer disconnects will be installed. If the disconnects will be exposed to moisture, dust, or corrosive substances, they should be rated for those conditions. Additionally, a disconnect should be installed in a location that is accessible for maintenance and repair. Sixthly, in some cases, it may be necessary to provide additional protective measures, such as surge protection devices, to protect the transformer and the electrical system from voltage surges. These surge protection devices can help to prevent damage to sensitive electronic equipment and improve the reliability of the electrical system. Seventhly, when working with transformers and electrical disconnects, it is essential to follow all applicable safety procedures and wear appropriate personal protective equipment (PPE) such as safety glasses, gloves, and insulated tools. Always to energize the equipment before performing any maintenance or repair work. Eighthly, it is recommended to consult with a qualified electrical engineer or electrician to ensure that the transformer installation is properly designed and installed in accordance with all applicable codes and standards. A qualified professional can help to identify potential hazards and ensure that the electrical system is safe and reliable. Ninthly, the location of the disconnect should be easily accessible and free from obstructions. This ensures that personnel can quickly and safely operate the disconnects in the event of an emergency. The disconnects should also be clearly labeled to indicate their function and the equipment they control. Tenthly, when selecting disconnects, it is important to consider the voltage rating of the transformer and the electrical system. The disconnects must be rated for the maximum voltage that they will be exposed to. Using disconnects with an inadequate voltage rating can result in electrical breakdown and potential hazards. 11thly, the disconnect should be installed in a manner that prevents accidental operation. This can be achieved by using locking mechanisms or other protective measures. Accidental operation of a disconnect can disrupt power to critical equipment and potentially cause safety hazards. 12thly, the disconnects should be periodically tested to verify their proper operation. This testing should include checking the continuity of the contacts and the insulation resistance of the disconnect. Testing can help to identify potential problems before they lead to equipment failure or safety hazards. 13thly, the disconnect should be protected from physical damage. This can be achieved by installing them in enclosures or by providing other forms of protection. Physical damage to a disconnect can compromise its functionality and potentially create safety hazards. 14thly, a disconnect should be installed in accordance with the manufacturer's instructions. Following the manufacturer's instructions ensures that the disconnects are properly installed and will function as intended. Failure to follow the manufacturer's instructions can void the warranty and potentially lead to equipment failure. 15thly, the disconnects should be inspected regularly for signs of wear and tear. This inspection should include checking the contacts for corrosion, the insulation for damage, and the mechanical components for wear. Identifying and addressing wear and tear early can help to prevent equipment failure and extend the lifespan of the disconnects. 16thly, the disconnects should be properly grounded to ensure that they are safe to operate. Grounding provides a path for fault current to flow back to the source, which helps to protect personnel from electrical shock. Improper grounding can create a safety hazard and potentially lead to serious injury or death. 17thly, the disconnect should be installed in a location that is well ventilated to prevent overheating. Overheating can damage the disconnects and potentially lead to equipment failure. Proper ventilation helps to dissipate heat and keep the disconnects operating at a safe temperature. 18thly, the disconnect should be installed in a location that is protected from the elements. Exposure to rain, snow, or other weather conditions can damage the disconnects and potentially lead to equipment failure. Providing adequate protection from the elements can extend the lifespan of the disconnects and improve their reliability. 19thly, the disconnect should be installed in a location that is free from flammable materials. Flammable materials can ignite if they come into contact with hot electrical components, creating a fire hazard. Keeping the area around the disconnects clear of flammable materials can help to prevent fires and protect personnel. 20thly, the disconnect should be installed in a location that is accessible for inspection and maintenance. This ensures that personnel can easily access the disconnects to perform routine maintenance and identify potential problems. Inaccessible disconnects can be difficult to service and may be neglected, leading to equipment failure. In summary, installing transformers requires careful attention to detail and adherence to the NEC requirements for disconnects. By understanding the purpose and function of these disconnects and following the guidelines outlined in this narration, you can ensure a safe, reliable, and code-compliant installation. Remember to consult with a qualified electrical professional for any questions or concerns regarding transformer installations. The importance of proper transformer disconnects cannot be overstated. They are critical components in ensuring the safety and reliability of electrical systems. Neglecting to install or maintain these disconnects can have serious consequences, including electrical shock, equipment damage, and fire hazards. Therefore, it is essential to take the time to understand the NEC requirements and to follow best practices for transformer installations. By doing so, you can protect personnel, equipment, and property from the dangers of electricity. And remember that this information is general guidance and you should always consult the latest edition of the NEC and with a qualified electrical professional for specific applications. Ignoring these steps can lead to dangerous situations. Always put safety first when working with electrical equipment. It is imperative to note that electrical codes and standards are subject to change. Therefore, it is crucial to consult the latest edition of the NEC and other relevant standards to ensure compliance with current requirements. Furthermore, it is highly recommended to seek guidance from a qualified electrical engineer or electrician who can provide expert advice and assistance with transformer installations and disconnect selection. These professionals have the knowledge and experience to ensure that the electrical system is safe, reliable, and code compliant. Remember, working with electricity can be dangerous, and it is always best to err on the side of caution. The line-side disconnect is not just about energizing the transformer for work. It also protects the upstream electrical system from faults originating within the transformer. A short circuit within the transformer could cause a large current to flow back into the panel, feeding it, potentially damaging the panel or other equipment connected to it. The line-side disconnect, especially when fused, interrupts this fault current, preventing further damage. The readily accessible requirement for the load-side disconnect is particularly important in emergency situations. If there's a fire or other hazard in the area served by the transformer, first responders need to be able to quickly de-energize the transformer to prevent further electrical hazards. A readily accessible disconnect allows them to do so without delay. When selecting fuses for the disconnects, it's not just about the current rating. You also need to consider the interrupting rating of the fuses. The interrupting rating is the maximum fault current that the fuse can safely interrupt. If the available fault current at the transformer location exceeds the interrupting rating of the fuses could fail to clear the fault, leading to a dangerous situation. The location of the transformer itself can also impact the disconnect requirements. For example, if the transformer is located in a hazardous location, such as an area with flammable gases or dust, the disconnects must be rated for use in that type of environment. This typically means using explosion-proof or intrinsically safe disconnects. In addition to the NEC, there may be local electrical codes or regulations that apply to transformer installations. It's important to check with the local authorities to ensure compliance with all applicable codes and regulations. The interconnection of line-side and load-side disconnects, when permitted for voltage conversion only, requires careful consideration of the control scheme. The interconnected disconnect should be designed to operate in a coordinated manner, ensuring that both sides of the transformer are de-energized simultaneously. This prevents the possibility of one side of the transformer remaining energized while the other side is de-energized, which could create a safety hazard. Regular maintenance of transformer disconnects is essential for ensuring their continued reliability. This maintenance should include visual inspections for signs of damage or corrosion, as well as electrical testing to verify their proper operation. Any damaged or malfunctioning disconnect should be replaced immediately. Proper labeling of disconnects is not just a matter of convenience, it's a safety requirement. Clear and accurate labeling helps prevent confusion and ensures that personnel can quickly identify the correct disconnect in an emergency. The labels should include the equipment served by the disconnect, as well as the voltage and current ratings. The type of enclosure used for the disconnects is also important. The enclosure should be appropriate for the environment in which the disconnects are installed, providing protection from moisture, dust, corrosion, and physical damage. Enclosures are typically rated based on their ability to withstand these environmental factors. Surge protection devices, SPDs, can provide valuable protection for transformers and other electrical equipment from voltage surges caused by lightning or switching events. SPD divert the surge current away from the protected equipment, preventing damage to sensitive components. The size and type of SPD should be selected based on the expected surge levels and the sensitivity of the equipment being protected. When working with transformers, it's important to be aware of the potential for arc flash hazards. Arc flash is a dangerous electrical phenomenon that can occur when there is a fault in the electrical system. Arc flash can produce intense heat, light, and pressure, causing serious burns and other injuries. To mitigate arc flash hazards, it's important to follow proper safety procedures and wear appropriate personal protective equipment, PPE, such as arc-rated clothing, gloves, and face shields. The NEC provides guidance on arc flash hazard assessments and the selection of appropriate PPE. The selection of disconnects should also consider the load characteristics on the secondary side of the transformer. If the load is highly inductive, such as motors or transformers, the disconnects may need to be rated for higher inrush currents. Inrush current is the high current that flows when an inductive load is first energized. Disconnects that are not rated for inrush current may be damaged or fail to operate properly. The altitude at which the transformer is installed can also affect the disconnect requirements. At higher altitudes, the air is thinner, which reduces the dielectric strength of the air. This means that electrical clearances must be increased to prevent arcing. The NEC provides guidance on directing electrical equipment for use at higher altitudes. In addition to fused and unfused disconnects, there are other types of disconnects that may be used for transformer installations, such as circuit breakers and motor starters. Circuit breakers provide both overcurrent protection and a means of disconnecting the transformer. Motor starters are used to control the starting and stopping of motors, and they typically include both a disconnect and overload protection. Choice of disconnect type depends on the specific application and the requirements of the NEC. The NEC also addresses the issue of transformer overcurrent protection. The overcurrent protection devices, such as fuses or circuit breakers, must be sized to protect the transformer from overloads and short circuits. The NEC provides specific requirements for the sizing of overcurrent protection devices for transformers, based on the transformer's nameplate rating and the type of overcurrent protection device used.